Okay, good. So let's continue. We're going to, having got our scatter plot, we can see a reasonably good linear trend. We're going to now add error bars to our data. So, clicking on the data point like that, we're going to go layout, and under error bar, we want to grab more options. Now, this is going to determine for us the vertical error bars first. So, in regards to vertical error bars, we have to make sure that direction is both up and down, and we've got a bit of a cap on the end, so we can see the box in the end. And we're going to custom assign our error bars because we have determined quantities for them. Alright, specify value. Alright, come to our data. Now this is where it gets a little fiddly, but we can manage. Now, which errors column are we going to use? What's important to remember is that vertical error bars, the vertical quantity on our scatter plot, pertains to the mass. So we need to make sure we select the limit of reading for mass. So positive error bar values, we're going to click and drag a whole range of cells for positive error bars. And the negative error bar values, again, come to the data like that, click and drag all those values. Hit OK. Okay, so there are the error bars are there, even though we can't really see them. Alright, and we can do something to try and fix it up shortly. Now, we've got these horizontal error bars which are not correct, so we need to fix them up. So if we click on the error bar like so, then come over to error bar and more error bar options. This time we're going to do the horizontal error bars. So again, direction has to be both, capped is on, and let's go custom. Specify value. Alright, so now positive values, we need to come over to our data and we can grab them over here. You can see in the corner behind it, it's a little difficult because this thing's in the way, but percentage error in volume. Now that's the data we want. That's all we've got at the moment presented to us. Now this is where we need to have an understanding of what these values mean. The percentage error isn't an actual size in volume for that estimates the error. It's the proportion. It's a percentage. It's saying 13%, 10%, 10%, 11%, 10%. So how much volume is that? And that's what really needs to be worked out. So we hadn't set up another column that determines for us the actual error in volume as a size in cubic meters. We've only got it as a percentage. So let's think ahead. Let's say that we do set up the actual error in volume as a size, and we set it up in this section right below. I'm going to highlight 1, 2, 3, 4, 5 cells. And in those 5 cells, that's where I'm going to put the actual error for volume. So click, and again the same for the negative error bars in those same 5 cells that I just highlighted. 1, 2, 3, 4, 5. Okay. Now there are no error bars shown at the moment because we haven't put in the values. So let's come back to the data. Let's have a look at, in these 5 cells, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That data there is going to be the actual error. Now, how do I work out the actual error from a percentage? I'm going to have to, treating that as a percentage, find what is the percentage of the actual value. So to do that, to work out the percentage of a value, I use multiplication. So 13% of multiply the actual value gives us that as a size, the error size of our actual volume of the pipe. And if I click and drag them down, it carries out that same formula for each cell. So in the last one here, the percentage, 10% of this volume, gives that as an error. Let's see how that looks on the chart. Oh, pretty. Alright, not too bad. Now, can't seem to see a vertical error bar. However, I can change the size of my marker. So I'm going to format data series. I'm going to go marker options. And I can change the size. Okay. And now it's a spec. But still, we can start to see the vertical error bars appearing. Okay. So there's our plot with error bars. Let's see if we can fit a linear regression line to that data. This line of best fit can determine for us a gradient. Oop, wrong one. It can determine for us a gradient, and the gradient of this line of best fit can give us an estimate for the density. Okay, the rise over the run, which will be the same as the mass divided by the volume. Mass divide volume. So go add tread line, and it needs to be a linear tread line, as we can see in the data. We want an equation of the chart so we can read what the gradient is. We don't necessarily want to set the intercept to 0, even though intuitively that may make sense, because if there's no mass, there's no volume, and vice versa. But because it's not experimental value we actually measured, we cannot include it. So do not tick set intercept to 0. This last box here, display R squared value on chart, that's going to give you a number between 0 and 1, and it's a proportion. You can think of it as a percentage on how good the line of best fit is. How accurate is it? Alright, so there's our data, and you can see the line of best fit passes through all the error bars, and we get an equation for our line of best fit. Let me put that, close, let me put that up here. Oh, I've kind of got it stuck. Here we go, put that up there. And if we look, it says a gradient of 8,233. And it's 99.7, 99.8% accurate. So that's pretty good. Let's pause there for a moment.